up, guys? We're back at it with lesson 5.2, part 2. Miss Legs, whatever class. Ka-chow!
Technically 5.2 part 1 and 2, just because we're going to review all the examples that you should have been working on Friday. So we're going to go through this quickly, not quickly, efficiently, where we don't waste any time with comments or ridiculous doodling or anything like that. I tried to look away and make eye contact with the wall instead of specific people. But yeah, no doodling. We're actually going to write down everything that I'm writing. We're going to pay attention the whole time. Does that sound good?
Yes, ma'am.
Great. Okay. It's going to start out simple. It's going to get a little more complicated, but pay attention from the beginning so that you know how to do it when it gets more complicated. Now, a little old expression called radical 63. I'd like you to meet my friend named Radical 63. We could also call this the square root of 63. Radical 63, square root of 63, same thing. So, if I were to find the square root of a number, I have a couple of options. My first option is to see if it's a perfect square, if I can get a whole number square root. Is 63 a perfect square? No. Give me a perfect square that's close-ish to 63.
64.
64.
Any even number?
Not any even number. A perfect square isn't a number that can be divided by 2. That's simply an even number. A perfect square is a number that has a root, a square root, that can be multiplied, that's a whole number, because it can be multiplied times itself to get that perfect square.
49.
49 is another perfect square that's
4.
close to
60.
4.
Oh, never mind.
Yeah, you were about to, it's okay. Just you're catching up. That's okay. I love the participation. 81. Give me some 100.
144.
She's 64. There you go. She's 144. That's right. You know how you can find a crazy perfect square? You take any number you want.
And multiply by
125.
You want to know a perfect square? 20,164.
Huh?
You know how I did that? I simply just typed in 142 randomly and then multiplied it times itself. I guess I gotta hit the square button instead of type that in again. How about 785 squared? I have another perfect square. 616,225. That's a perfect square because it has a whole number square root.
144.
Very good. Already said it, but it's okay. I'm glad you're participating.
125.
120. No.
Yeah, it's 5 times 5 times 5.
That's a perfect cube.
Dang it.
James.
Very good. I love it. Perfect cube. Yeah.
I got it. 321035556.
Huh?
Totally knew that. What's the square root?
5666.
5,666 squared is that number. Okay, I love it. So we understand what perfect squares are. They're quite rare, right? And the higher the numbers go, the more kind of spread out they are, because the lower numbers they're pretty close together. 4, 9, 16, 25. We have a bunch of perfect squares in the lower numbers. As we get higher, the numbers get more spread out, right? So there are lots of perfect squares. There are an infinite number of perfect squares. Jack, it's really distracting for me, okay? Probably for other people. And so is the humming. So let's just try to be quiet and focused, okay? So if we look at that number and say, oh, I just want to get the square root of that and solve it. Well, it's not a perfect square. Now we can put it into the calculator and see what the square root is. 63 square root. 7.937253933 ... I wouldn't be able to tell you the square root of this because the decimal continues on forever and doesn't repeat. So I can't simplify that without rounding it. I can't simplify it exactly by doing the square root, but I can pull out a square root, kind of like pulling a rabbit out of a hat. I can look inside of a 63 and see inside of that 63. If there's anything inside of the 63, that is a perfect square. Yes.
97.
Well, answer my question. I said, let me look inside of the 63 and see if I can pull out a perfect square. 9. Because 63 can be broken down into
9 times 7.
Yep. Now, because we're talking about radical 63 or square root of 63, we're going to write it as square root of 9 times square root of 7. Okay? This still belongs in a square root home, so its factors will also be represented as the square root of 9 and the square root of 7. Yes?
Isn't the square root of 9 3?
Yes, it is. That was my next part. The square root of 9, or I should say 9, is a perfect square. So the square 9 is a perfect square, so I can free it from its radical cage, and it becomes like a little free bird flying free. So radical 9 became 3, no longer in its radical cage. Now, radical 7, can we find the square root of radical 7? What's square root of 7?
3.5.
3.5 times 2 is 7. 3.5 times 3.5 is not 7. We still, and this happens, we still get confused the difference between a square root and dividing something by 2. They're not the same thing. The only time that's the same is with the number 4. It's just a coincidence. Yeah, that's correct, and it's not even like close to that entire number. Since we can't find the square root of 7, and we can't break down 7 any further, it's going to stay in its radical cage. It's very sad. So 3 times radical 7 is simply 3 times radical 7. Now this is very important. Has anybody heard of the band from the 90s, the Smashing Pumpkins?
Yes.
Oh, thank you. Every other class is like, huh? You're old.
What?
Does anybody remember the song? Despite all my rage, I'm still just a rat in a cage. That's how he sang. I know it sounds like I'm being weird. That's honestly what he sounds like. You've heard it? Doesn't he sound like that? Despite all my rage, I'm still just a rat in a cage. That's legit what he sounds like. Where's my phone? Oh, I'm recording. All right, you don't believe me?
Computer time.
Alright, let's do this.
You don't believe me?
I'm a rat in a cage. Yeah.
Here we go.
I'm a rat in a cage.
I'm not gonna,
Back in my day.
Alright.
I was about to That's my rat in our cage.
Question number
Ready to take your business to the next level?
all right, you ready for some 90s? Ready? I told you he sounds like that, right? Why are we listening to that? Because of this. This is
The
this.
radical cage.
Yes! Woo!
Oh, I thought you
I
said
agree.
The radical cage. Instead of rat in a cage. Ow! Ow! Gosh, you guys are violent. Okay, so this is the jailbird song. This is the jailbird song that the radicals sing when they can't be freed from their radical cage. So this bird is like, I'm free as a bird. That's a Beatles song, by the way. And this guy's like, despite all my rage, I'm still in my radical cage. Like that. Oh, I'm sorry. Is that too silly for you? No, am I embarrassing you?
Yes.
Oh, I'm sorry.
At least they're honest about it.
Yeah, at least you're honest.
Wait.
If you say yes,
Something tells me
you're just gonna do
you're paying
it.
attention
I
now.
know.
And I don't care if I can make a full last on camera for all the world to see. What?
So 63 is like, I want to break free.
I want to break free.
Yeah.
I want to break free. Okay.
That's my favorite song.
Really? Good song. Why are we talking? We still have a lot of work to do. All right. So that's the theme of this lesson. Some things are gonna become free as a bird, and some things are gonna stay in their radical cage and sing that like really angry, aggressive song. So this example, I'm actually not gonna use the exponent 7 because it kind of overcomplicates things a little too quickly. I'm gonna rewrite this. I'm gonna redo this example, so don't write this. I'm gonna do the square root of 2 to the 6th power times 5 squared, okay? Do you agree that the square root of 2 to the 6th times 5 squared can also be written as the square root of 2 to the 6th times the square root of 5 squared?
Yeah.
I think so.
Yeah. Now, do you also agree that this square root sign has an invisible number that we cannot see
Yes.
right now? What is that invisible number? It's 2. It's this little index, 2. Do you also agree that I'm allowed to rewrite radicals
Yes.
with rational
Yes.
exponents? What's a rational exponent?
Fraction.
A fraction.
No, don't.
Now don't hurt me or each other. Scary.
Wait.
Shh. I gotta move on. If I rewrite this with a rational exponent, what does that look like, Carmine?
2 to that.
Anybody? Jacob.
Oh, shucks.
Not 6 over 1.
2 to the 6. Like,
Oh, I know. 2 to 12 over 2.
No.
6 over 2.
6 over 2. Okay, so just a friendly little reminder, we went over this when we were doing the lessons from the previous book, and then we did it in our review, where we wrote that the index or the root, whichever one you want to call it, is the denominator, and the exponent is our numerator. So we can rewrite these numbers as a rational exponent. The exponent is always the numerator, the index is always the denominator. Now that I have it as 6 over 2, can't that be simplified?
Oh,
Yes.
yes.
What's 6 over 2?
3.
3 over
3.
1.
So 2 to the 3rd power can also be simplified. What's 2 to the 3rd power?
8.
8. So now, this little birdie, this little jailbird, stuck in its radical cage, just shimmied its way out by being like, no, I don't belong here. I was innocent. You see?
Elmo.
Okay, I actually do a really good Elmo, but that's a whole other lesson. Okay, so, shh. So this guy's like, no, I'm innocent, I swear. I'm not really supposed to be a jailbird. I'm supposed to be a 2 to the 6 over 2 power. And then that really is 2 cubed. And now that I'm an 8, so I can fly away. Oh, glory, I'll fly away. So he flies away and he's free as a bird. And this guy's like, me too. I didn't do nothing. I'm just over here, 5 squared. The square root of 5 squared is what?
You sound like an Italian boss.
It's 5.
I'm walking.
It's 5. Because it's 5 to the 2 over 2.
I'm walking.
Or I
my
can.
ancestors goes
Uh-oh. I can teach like a really boring math teacher
Yeah.
if you want me to. You guys gotta let me keep going, okay? 5 to the 2 over 2. Look at me, I'm just innocent. So 5 to the 2 over 2. I wasn't doing nothing. Just 5 to the 2 over 2. That's 5 to the 1. I'm just 5.
She's walking
Free
in.
as a bird. No more radical cages.
Yeah, bear.
8 times 5 is 40.
Did you say 30?
I said 40.
Oh.
Now,
So in my
I'm gonna leave this here for a second.
Oh.
I'm going to just show you, you don't have to write this if you don't want to, but I want to show you how it would look a little bit different if we did actually use the 7. I'm gonna erase that equal sign because this is separate.
Oh, but you just changed it to a 6.
I did change it to a 6 to use it as an easier example, but now that we know how to solve it, I want to go back to this. Now, if I try to do the same thing and this little birdie's going, oh, I'm innocent, I'm really 2 to the 7 over 2 power. And then it's like, but that 7 over 2, that can't be divided, it's really hard. So maybe this little birdie has to separate from one of the 2's.
No.
And instead of 2 to the 7,
Depressing.
it'll be 2 to the 6 times
Two.
2.
Oh, that was
Just 2. 2 to the 1.
Wouldn't they still be?
Now, the 2 to the 6 can break free. The square root of 2 to the 6 is still 8. Is still 8. But this 2, the square root of 2,
He's Mr. Lonely.
still a jailbird.
Oh yeah.
Despite all his rage. He's still in his radical cage. That's right, I am gonna sing again, you just won't know until it hits you. Okay, and then of course 5 squared is the same, I didn't change that, so that would still be 5. When you square root that, when you square root that, so this will also be free as a bird. And again, we can have our 8 times 5, which is 40, times the radical 2. So these guys are free as a bird, Beatles. And this guy is, despite all my rage, I'm still just a radical cage. No, I don't want to. I don't have a minute to give you. I have to teach the rest of this lesson. So let's move on. Yeah.
You sound like you're
40?
8 times 5.
Gate. Voice. I said gate. I thought you said voice.
Definitely. You gotta take them? All right, no try-its today. We're just going through the examples.
Wait, I'm gonna try it again.
Alright.
Oh, whoops. Did I freeze it? Oh yeah, because I was
Rose
unmuted.
toast.
Okay.
What am I
Here's some,
looking at?
yeah, this is,
Why are there so many dots?
why are you looking at this like it's the first time you've seen it? This was one of the examples you were supposed to expose yourself to on Friday.
Oh,
Then why do you look so surprised?
it's just a lot to take it.
Yeah, right, yeah, you
I
should
watched
do
the
some.
videos first.
Oh, and then after that, did you actually do this? No, I watched the videos and then I didn't want to, and Mrs. Blake wasn't here, so I did whatever I wanted. The square, like,
The
uh-oh.
cubed root.
We're not talking about square roots anymore, we're talking about cubey roots.
Oh, sure.
Oh no, and there's a negative. It's gonna get crazy, so
Crazy?
buckle up. It would have been awesome if you took more notes than that, Lily. It would have been so awesome.
So radical, dude.
It would have been radical. That was Jolly Rancher worthy. Just kidding. That would be so mean. Here you go. Calm down. All right, so we're definitely going to take notes every time I'm writing. You're writing too, okay? Let's make that just a thing that we do every day so I don't have to keep saying it. Okay, now, there's a lot going on here. Do you agree that since they both, that's exactly right, since they both belong to the cubed root club, you could rewrite this to be the cubed root of 45 times negative 75. They both belong to the cubed root club, so you could just put them together, the multiplication of 45 times negative 75 in the cubed root club, okay? The cubed root cage, I should say.
Oh.
You want me to say it again? Okay, no, we have to see if they can get free as a bird. Now, there's a lot going on here. We're going to have to break things down. And from when they get more complicated like this and we have to kind of join numbers together, what we actually want to do is use prime factorization.
Uh-oh.
Factor trees, yay!
Oh no.
Well, you're
Because birdies like to
Break.
Fly in tree.
fly into the trees, not like
Make a
into
nest.
them, and make a nest. So the birdies are like, hey, check out my factor tree and my nest in my factor tree. So here's 45 at the top of his factor tree, okay? And we're gonna break it down. We gotta go quick. Hurry, hurry, hurry. Break it down.
5 times 9.
5 times 9.
8.
Huh?
That's 40.
Oh, yeah.
Okay.
what?
Prime.
15 times 3.
I've already.
3.556893330.
Okay.
5, 3, 3.
Wait.
Now, I've got my 45 and I'm also gonna do my, oh, here's where it's gonna get crazy. Okay, now my negative 75, I'm gonna do over here. Negative 75 we have a negative number, which means a negative is being multiplied times a positive. Before we break it down into all those prime factors, let's factor out the negative. How can we do that without breaking it down into like smaller factors?
You just take it out and then at the end.
Kind
Negative
of.
times a negative
The
one.
dungeon.
What?
Negative times negative one.
Negative times a negative 1?
Yeah.
A negative times a negative is a positive. So we want to get a negative 75 with two factors without breaking it down to other factors. Yeah.
So basically just like times 75 by like
Yeah. By what? What do you multiply 75 times to get negative 75?
One.
-1.
Negative 1. Very good. So this factor tree is going to start with, it's going to start with a negative 1 times positive 75. Shh. Circle that, we're done.
Oh.
Now 75 can be broken down into a couple of different ways. What? And how about 3 times 25?
Sure.
Prime, and then 25 would be
5.
5 times 5, prime, prime. Now, since I factored everything out, all this is being multiplied together, do you agree that I can rewrite this again? You guys should already have this down, I'm erasing what's in here. I'm gonna rewrite this to now have all of the factors of those numbers. 3 times 3 times 5 times -1 times 3 times 5 times 5. I'm erasing this factor tree. So I got it down. Now that I've broken down all of these, both of those numbers into all of their prime factors, notice how we have a 3 times a 3 times a 3. What's that?
Oh,
Times
squared.
3. 3 times 3 times 3. It's 27, but we can write it as 3 cubed, right?
Yeah.
So I'm going to rewrite this. 3 cubed. Whoops, that's a square. 3. So I need to write the cubed root of 3 cubed.
And there's also 3 5, so it'd be 5
Times
as well.
the cubed root of
5.
5 cubed. I'm going to cross out every number
And
that
then
I...
times -1 because he's depressing.
Times the cubed root of -1.
Yippee.
What's the cubed root of 3 cubed?
3.
That one.
Just 3.
It's just 3. Because it's 3
Because he wants to
to
break
the 3 over
3.
3 power,
Which cancels out.
which cancels out to 1. 3 to the 1 power is
So
3.
it's all the same. So it's all 3, 5, and.
No, I mean, yeah.
3 times 5 times, now this is weird, it's like, wait, can you get the cubed root of -1?
Yes. Because 3 over 1 is still. Wait.
I want to break free.
Well, think about it. What number times itself and then times itself again will get you -1?
Nothing.
One.
-1.
Negative
-1.
one.
-1.
Oh, fourth one?
So this little sneaky bird got out of jail.
That one. He used the loophole.
Yes. He's like, I didn't do nothing. I've just been a -1 this whole time. You can cube me anytime you want. And you can find the cube root and I'll still be -1. I'm free as a bird. So now we have these free birds, nothing stuck in the radical cage, which is very sad because I do like singing that song. 3 times 5 is 15 times -1 is -15. So this crazy expression simplifies to -15.
Oh, that worked for that.
Yup. Welcome to math.
Good thing I got the. No. I thought the freaking math. The math one was easy.
It was easy.
It was not.
Yes, it
The
was.
other one was easy.
The math was pretty hard.
The math one was good.
I used the math.
Hi, welcome to my class. Be quiet. Do you have to? You really have to. Okay, just go. No knocking right now. Can you do that the entire way there, please?
I could have.
Thank you.
I'd like to see that.
Thank you. People are gonna think there's like a fire or something. Stop, drop, and roll. Okay, now. Is it doing it? Perfect. Now listen, we just multiplied radicals. Now we're going to divide radicals. Now here's the cool thing. When you divide radicals and you get matching
Pairs.
pairs in your numerator and denominator, you can cancel them out. So this one's like you have to combine and you get all these like crazy exponents. These will cancel. So again, if they each belong to a cubed root club, then they technically, the whole thing belongs to the cubed root club. So you can write it like this, so that is it okay that I'm writing like over that? You can still see it, right? Okay, so I'm gonna break 15 and 3 down, that's easy. What is it? 3 times 5. Can somebody try to like, tell me the answer before I do it? 'Cause it's
Yeah.
just like, and not just Carmine, because Carmine is very, very good at participating, but I need more of you participate. Okay, but listen, if you participate, that's great. If you don't, start participating, okay? 3 times 5, and then 405, we're gonna need a factor tree for that. 5 times 81, okay, I'm just gonna do it. 81 is,
9 times 9.
thank you,
3 times 3.
thank you. Prime, 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 prime. So I'm gonna write that. I like to go in order from least to greatest. 3 times 3 times 3 times 3 times 5. Technically, you could write 3 to the 4th power, and then you could subtract your exponents, but this is a little bit easier because it allows you to like match up the pairs. So cancel, 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 cancel.
So it's just 3 cubes?
So, good question. Shh. What's in the numerator?
Nothing.
Not nothing.
1.
1. Because that cancels out to 1, that cancels out to 1. So now we have the cubed root of 1 over 3 cubed.
Flippies?
Not flippies, there's no negatives. So the cubed root of 1 over the cubed root of 3 cubed. What's the cubed root of 1?
1.
1. What's the cubed root of 3 cubed?
3.
3. Very good. Done.
Nice.
I feel like this is a whole lot of effort, just like 1/3.
I know.
It's that easy, guys.
It's not easy. It's not. I don't think it's easy. Every time I teach this topic, I have to like review it myself.
Wait, Miss Leg.
Yeah.
How did you get 3?
Down here?
Yeah.
So over here, over here in the denominator, we had 3 times 3 times 3. So I wrote that as 3 cubed, and it's the cubed root of 3 cubed, which is 3 to the 3 over thirds power. See it? Oh my God.
You're like 3.
We gotta keep going, people. Okay. Now we're gonna multiply radicals that also have free birds. No big deal. No big deal at all. This is like not even really any different than what we just did. So we're just gonna practice it again. 3 radical 10 times 2 radical 120. Do you agree that this 3 being next to the radical 10 is saying that 3 is being multiplied times radical 10?
Yes.
Okay, so 3 times radical 10 times 2 times radical 120. Do you agree that the commutative property of multiplication says that I can multiply these in any order? I don't know why you're showing me that.
So radical 10 times that by 3.
So if you want to try to write that as an answer, you know the calculator ends and can't continue all those numbers that keep going on forever. Forever. Do you understand? Forever.
I love
Yes.
that.
Another
Bird.
homage to the 90s. Okay.
Sandlot. Sandlot.
Sandlot, yes. Now, do you agree that because of the commutative property of multiplication, I can multiply these if I want to and put them over here? I can change the order and I can multiply these. Now, I can also do the square root of 10 times 120. Because they both belong to the square root club.
Of 2.
Huh?
Oh, there's the invisible too.
Oh, the square root, yeah. So 3 times 2 is 6, and then that's being multiplied times 10, the square root of 10 and 20. So let's break those down.
120.
10, yeah, 10 and 120. Break those down.
5 and 2.
Yeah, thank you. Somebody say them before I do them. Well, okay, I guess I'll just do it all on my own.
Times
6, 2
3
times 6,
times 2. 5 times 2.
5 times 2,
And then you're good.
Good.
This many.
So, can I use all of these prime factors and just kind of line them up? I can even pull out my, I can even go like this. 1, 2, 3, 4. So that's 2 to the 4th power. So that covers the 2's. And then it's 1, 3.
And then 5 to the second.
5 to the second. So times 5 squared. Now, do you agree that I can make my little invisible 2 show up since there's no index there?
Yeah.
So that's a square root of, so I can do 2 to the square, the square root of 2 to the 4th power. What's that?
2 to the second.
2 to the second. Very good. It would be 2 to the 4 over 2, which is 2 to the second, which is 4. And then 3 is going to be what?
Just
Or the square root of 3 is going to be the square root of 3,
Oh.
despite all his rage. And then the square root of 5 squared
5.
is 5. Very good. Free as a bird. Now, the 4 and the 5, what's going to happen to them?
Multiply.
Multiplication.
Times what?
The 6.
Very good. The 4 and the 5 move to the free, the get out of jail free card. And then, so that would be 6 times 4 times 5 times the square root of 3.
20, so it'd be 24
20 times 6 would be
5, that'd be
120.
120
120, very good.
times,
Radical 3. Because these are free as a bird. And this is, despite all my rage, I'm still in my radical cage. Ah. Jocelyn, can you keep comments like that to yourself? They're not helpful to our lesson, okay? And very disrespectful to a teacher who's trying really, really hard and making an idiot of herself on camera. All right, so what I want to do for this one, we actually might go for the gold here. Okay, for example 5, I'm actually going to do the try problem because it's much simpler than the example problem. I don't know why they're making the example problem so complicated.
why not?
Because why not? Okay, so this little thing, these little jailbirds want to break out. Bo, put that wrapper away, you're driving me nuts.
And I'm trying to like get it so I can just throw
Okay.
it easily.
Let's rewrite this with prime factorization, okay?
9
63,
times 7.
thank you.
3 over 3.
3 times 3. Bo, you should be taking down these notes.
I'm so sorry.
98,
Oh god. Oh no.
2 times 49,
Okay. 49.
7 times 7, thank you. I just don't know why. I don't know why you wouldn't want to pay attention to this. It's just like you have tests and quizzes and an EOC to pass. Okay, so when I get my prime factorization, I have 2 times 7 times 7. And what can I do here?
Oh,
Cancel.
7 and then 7.
Yeah, 7 over 7 cancels. Anything else?
No.
No. So I have the square root of 3
to the
squared over the square root of
2 times 7.
2 times 7, which is 14. Okay. Despite all his rage, he's still in his radical cage. Lily, no need to pack anything up.
Oh, I was
Okay. So the square root of 3 squared is
9. Or
No.
no, 3.
3, because that's 3 to the 2 over 2, 3 to the 1, 3. Free as a bird. Now this, despite all his rage, he is still in his
Radical.
Radical
cage.
cage.
radical cage.
Rat cage.
Now, it's like, wait, are we done? Did we just do this?
No.
Here's the little thing about fractions and radicals. The general rule is you're not allowed to call this simplified because you're not allowed to have a radical in the denominator.
So you do flippy.
You can't do flip. You can't just like, oh, it'll just erase it. And it'll just be 14.
Yeah.
We have to change this, and we have to figure out a way to break it free. We're doing a jailbreak here. We're gonna break it. We're gonna break it free.
I got this.
He's in the
Dude,
clink.
break.
He's in the clinker. I want to break free. Okay.
2.41.
He wants to break free, so he needs a little help.
Yeah, Joe.
What can we multiply radical 14 by to break him free? It wouldn't be 2. 2 would just be.
Four.
No, that's 7 times 2.
So you've never been.
What?
Round 14.
Yes, you little genius.
You're such a
Oh,
genius.
wait.
What is it?
I
So
thought.
basically you just square it.
Yep.
Yeah,
Yes, exactly. Basically, if you square this or multiply it times itself, it will break free of its radical cage and no longer have a radical in the
No
denominator.
kidding.
Now, we can't just go around multiplying things times radical 14
Oh.
unless
You do it to the numerator.
we do the same thing to the numerator. Because we know we're allowed to multiply fractions times 1,
So it would be 3.
because that doesn't change anything.
Oh,
So this guy got to break free, and this guy,
it's still free. He just has a friend
he's
that's
still
not
free. He's just like, now he's got like a friend on parole,
It's
basically.
20.
So even though this looks like a nice simple answer, it's not good enough. It actually has to be this, which looks more complicated, but it's not breaking the rules. You break the rules, you go to the clink.
What?
All right, guys, I'm very proud of you guys because this is the first class I'm actually able to get to these last examples. So let's do this, and that's good for the recording. Okay, this is going to be the easiest one you've ever done in your life. Are you ready? I promise.
Yeah.
Easiest one ever. If I hear that rap again, I'm gonna lose my mind. I actually thought it was well. I was going to make a big deal. Well, because I already told you not to. That's why I was going to make a big deal. Okay. Shh. 12 radical, it says, what is the sum of 12 radical 7 and 6 radical 7? 12 radical 7 plus 6 radical 7. I've got great news for you guys. Radicals that are the same, they're kind of like denominators.
Oh, you can
So
cancel
they
it.
don't cancel out. Just like if it was like 12 over 7 plus
Oh.
6 over 7, what would you get?
You would just
add
You get 18 over 7, right? You would just
have to
add.
add 12.
Yeah, so this isn't the same problem. I'm just saying it acts like the same thing. If they are the same radical, you can add your numbers, 12 and 6,
18.
and then the radical joins together, stays the same. So it'd be 18 radical 7.
Why would it be squared though?
Because you're not multiplying them.
Is that all we have to do for that one?
What's up?
Is that all we have to do for that one?
Yeah, then there's B and C.
Oh,
Okay. We're gonna, oh, it's on the slide, which is in Canvas.
And it's on the video.
Yeah. Okay, so now it's asking for the difference between these two. Now that looks really weird. We're gonna have to subtract 10 radical 3 minus how much? Okay. 10 radical 3 minus 6 over radical 3. Now, what's this over?
1.
What's the only way I can subtract fractions if I have
another fraction.
common
Denominator.
denominator? So I have to change this to have a denominator of,
3 radical.
oh, or actually, I'm gonna go about it another way. I'm going to, you can go about it either way, but you'll actually end up having to convert it back. So I'm going to get rid of this radical cage, and I'll have 10 radical 3 minus, I'm gonna do 6 radical 3 over here, and I'm gonna multiply that times what to free it from its
Radical
radical cage? radical 3, so I do the top radical 3. 6 times radical 3 is 6 radical 3. Radical 3 times radical 3 is 3.
3.
6 over 3 is
2.
2. Cancel. So this changes to 2 radical 3. So I have 10 radical 3 minus 2 radical 3.
And then
which
after
is
that, you minus the 10 by 2 and you get 8 radical 3.
That's it.
I'm a good child.
All right. Oh, this is so easy. Ready?
Oh.
What is the sum of these?
Yes.
You cannot combine. You cannot combine square and cube roots, so the sum is the same as the question. 2 radical 5 plus 8
Oh, would it be two?
cubed. It would be nothing.
It
Would be
Zero.
nothing.
It's 0.
It's not 0.
It's the
just
same.
it's just as simple as it can be, so you don't have to do anything.
Is that on our homework
No.
No.
or any of the?
But I can add it if you'd like me to.
No.
Okay, because I only
All I
shoot.
have to do is like, you just like switch some of the questions out for that one. So we just have to copy it down.
I cannot believe we finished.
Both.
The expression does
No.